Okay, so to determine if a system is a group, you've got to check off all four of these properties, which we've studied in previous videos here, okay? So let's check closure. Closure means you can't get any elements outside of the set, okay? Outside of the system. So like the elements of our system are little circle, square, triangle. Little circle, square, triangle, square, little circle, square, triangle, square. All these are possible elements of the system. So we're okay. It's closed, okay? The associativity property, it's easier when you got a 3x3 matrix, okay? Associativity means the order you do something in. So like A, star, square, star, triangle. If anyone hears you talking to yourself about this, they're not going to think you're doing math. A star, square, star, triangle. So these two need to be equal if we put a parentheses there or if we put a parentheses there, okay? So circle on the row, star square, so square in the column, circle, star, square gives us square. And then we have square, star, triangle, square in the row, triangle on the column, square, star, triangle gives us square. Notice I just picked the first three as they came to me. You can rearrange, okay? So square, you could pick any you could do square, square, triangle. You could do triangle, circle, square. You know, picking circle, square, triangle was arbitrary. You could have chosen any three elements you wanted to start with. But square, star, triangle. Square, triangle makes square. You battleship them up, okay? And then circle, star, square gives us square. So that checks out. So that's just one example. You need to check all the examples to make sure it's associative. But sometimes what I do is I look and see if I can find some sort of pattern or symmetry. Like these triangles are opposite of one another, the small circles are opposite of one another, and the squares are in all four corners. It looks like there's some symmetry happening here. And we could divide on this diagonal line and get the same figure. So let's see. Let's just do one more for good measure. Triangle. I'm going to use dots instead of drawing the stars, okay? Let's mix it up. Circle, dot, square. See if that's equal to triangle, dot, circle, dot, square. It's stars instead of dots. I'm just saving myself some time. So parentheses around those two. Let's see if it's the same thing as parentheses. So triangle, dot, circle. So triangle in the row, circle in the column makes triangle. Circle, dot, square makes square. Okay, circle in the row, square in the column gives us a square. And those are going to be the same thing, right? It's looking associative, so we're going to put, I think it's a check. An identity element. That means you should be able to put it should always spit out the other element you're pairing it with. So circle paired with circle gives us circle. Circle paired with square gives us square. Circle paired with triangle gives us triangle. But make sure not to just check it by columns. Make sure it goes the same way across the rows. Circle paired with circle gives us circle. Circle paired with square gives us square. Circle paired with triangle gives us triangle. So that little circle is the identity element. Okay, so that's checked off. Invertibility, that means that you can get the identity element for any other element. So like, for instance, for this circle, you can get the identity element by pairing it with the circle. So it's invertible, okay? If you, for square is an invertible, you should be able to pair it with something and get the circle. And you can itself, right? Square paired with square gives you circle. So it's invertible. Because triangle paired with triangle, you can find something to pair the triangle with to give you the identity element. So it's invertible. So yes, this is a group. Heavy stuff. Okay, let's try another one here. Same question. Is it a group? Man, it's a lot bigger, so. Closure. Closure is a quick one to check. You just look at all these possible elements, make sure that they're elements that are across the row or across the column. 30, 40, 50, 60. There's only 30s, 40s, 50s, and 60s, so it is closed. Okay. Let's check the identity and invertibility first, because those are a little quicker, and that might help us eliminate some answers. The identity element, you must be able to pair the element with something else and get back whatever you put into it at first. Okay. So 30 pair with 30 spits back out 30. 30, if you pair it with 40, it spits back out 40. 30 paired with 50 spits out 50. 30 paired with 60 spits out 60. So it's looking like 30 is. And if you go across the row for 30, 30 and 30 make 30. 30 paired with 40 makes 40. 30 again across the row is spitting out the element you pair it with. So 30 looks like it's the identity element. We have an identity element, so we can check that off. And for it to be invertible, it means you should be able to get the identity element from some sort of operation. Okay? So in other words, you should be able to get out 30 for each element. Should be able to pair like 40 with some other element and get out 30. And we can, right? 40 star 50 gives us 30. So 40 is, we'd say that's left invertible. You want to check it right. 50 paired with 40 gives us 30. So that checks out. 40 is invertible. We need everything to be invertible though. 30 paired with 30 is 30. That one's invertible with itself. So 50, if you pair it with 40, 50 star 40 gives you the identity element, 30. And if you switch that order, 40 paired with 50, that gives you 30. So 50 is invertible. 60 paired with 60 makes 30. 60 paired with 60 makes 30. If you switch that order, it's invertible. Oh, so the last one is the associative property. Associative is tough. I'm not sure if what I'm about to say is 100% true, so maybe I shouldn't say it. Take this with a grain of salt, but I look for symmetry, okay? Like if you imagine a diagonal line cutting through these numbers, then the diagonal line has symmetry. And usually if it has symmetry, it seems to be invertible. But anyway, not invertible, associative. Okay, so for it to have the associative property, you should be able to take 30, and I'm going to use dots instead of stars to save time, okay? 30 star, 40 star, 50. If you do 30 and 40 first, that should equal 30 star, 40 star, 50. Okay? So if you go 30 on the row, 40 on the column, you get out 40. And if you go 40 on the row, 50 on the column, you get out 30. So you got to do parentheses first. So 40.50 gives us 30. And 30.30 gives us 30. So that's true. It need to be true for every possible operation like that. Let me see what I can do. There should, instead of trying to check every single possibility with associativity, let me see what I can find. Yeah, because you'd have to check for every single element. We did 30, 40, 50, but you have to check 50, 40, 30. You have to check 50, 40, 60. don't think I haven't found anything that makes it quicker. I found something called Light's Associativity Test. I've never done it. It's going to be too long for me to figure out in this video. We checked one. Let's just check one last pair. That one was using 30, 40, 50. Let's see if it's associative by just checking one more time. Let's do 30.40.60 and see if that's the same if we do 30, 40 first. That's 30.40.60. Okay, 30 on the row, 40 on the column gives us 40. 40 on the row, doing this parentheses over here. 40 on the row, 60 on the column gives us 50. 40.60 gives us 50. And then 30.50 gives us 50. It looks associative. I've done 2 examples. So this is still in question. Phew, okay, it was associative. But again, I couldn't be certain unless I did every possible example.